Let's take a look at Project 3 for Algebra 2B. This is the first portion that corresponds with Lesson 11. So, the graph of an exponential function has a blank that defines the blank of the function. The graph of a logarithmic function has a blank that defines the blank of the function. We have to match the blanks. So, because we are dealing with so many blanks in our sentence, I know it can be a little bit confusing at first, but use the context to get yourself started on these questions. So it says the graph of an exponential function has something that defines something else. So I would say our first step is just to take a look at the graph of an exponential function and kind of see what's going on. Let's keep in mind our answer choices, okay? So we have three different types of asymptotes. We have horizontal asymptotes, slant asymptotes, and vertical asymptotes, okay? So chances are that these asymptotes are either going to fit the first blank or the second blank, right? One of them is. So we kind of have to ask ourselves, do you think we're going to figure out that an asymptote defines some other value, such as the base, the range, or the domain? Or is it the other way around? Does a base, range, or domain define a certain type of asymptote? So let's take a look. So I'm just pulling up this sort of standard graph, and I'm going to type in an exponential equation. I'm going to keep it simple. I know you can't see the input I'm typing in because it's kind of cut off on the bottom. Doesn't matter. I'm going to type in the function f of x equals 2 to the x. Okay, so keeping it a pretty simple exponential function. Alright, so we know that this is going to have some sort of asymptote. It's kind of hard to see here. Let's zoom out. So as I zoom out, the question is, and remember this is an exponential function. As I zoom out, the question is, am I seeing a horizontal asymptote? Am I seeing a vertical asymptote? Am I seeing a slant asymptote, which would be 1, and I'm just going to change the color so you can see it a little bit better. A slant asymptote would be one that goes kind of diagonally. It isn't an asymptote that runs parallel to either the x or y axis. So again, looking at this, do you see a horizontal or a vertical or a slant asymptote? And let me just graph another exponential function just so we get another example. What about this one? 5 to the x plus 10. Oops. There we go. So here's just another one to look at. And again, zooming back in, does this seem to be a horizontal asymptote, a vertical asymptote, or some sort of slant asymptote? So that's the first thing I would sort out. What sort of asymptote do you associate with an exponential function? Horizontal, slant, or vertical? Remember, horizontal would look like that. A slant might look like this or like this. And of course, a vertical asymptote would run straight up and down. I know my lines are a little crooked. All right. So are you seeing horizontal? Are you seeing slant? Or are you seeing a vertical asymptote? And then you decide, all right, well, does it have an asymptote, again, that defines something, or does something define the asymptote? And just ask yourself what makes sense. What I might do at this point would be to pair up, like looking at the other words, for example, domain. When you think of domain, what do you associate it with, right? We normally think of domain as being, is it x or is it y? So figure that out. And then does domain make more sense? When we're talking about domain, are we usually talking about things that are horizontal, that are slanted, or that are vertical? Okay, so hopefully you see what I mean by that. So I would pair up the asymptote with its corresponding word that it seems to go with. So I do that for horizontal. I do the same thing for vertical. Range, for example. When I think of range, do I think of things being horizontal, slanted, or vertical? So I would pair off your asymptote and its complementary word like that, and then you have to determine, again, is the asymptote the thing that's defining something else, or does that other thing define where the asymptote is going to be? Let's take a look at the next question. If an exponential function is of the form f of x equals b to the x plus c, and b is greater than 1, then it is what? Is it increasing, decreasing, or constant? And then they'll ask us again, this time with a logarithmic function of the form, I think this is supposed to be log base b of x plus c, then is it increasing, decreasing, or constant as it approaches infinity? Here's what I would say. Once again, let's take a look at a graph. So I'm going to minimize this graph just so we can kind of see our question at the same time. I'm going to delete my old examples. So the question was, if an exponential function, let me give us some more room here. If an exponential function is of the form f of x equals b to the x plus c, where b is greater than 1. So we need to type that in. So I'm going to have an exponential function of the form f of x equals b to the x plus c. Now all I've typed in so far is b to the x plus c, but I actually have to type in, numbers to get a real example. It tells me that b is going to be greater than 1, so I can pick any value greater than 1. I'm going to pick, 1.2, okay? Just because that's some number greater than 1. And then plus c plus some constant, I'll pick, 7. Alright, so I've graphed that. You can see the graph pretty well, and the question is, let's get rid of the grid lines here, if we can. Oh, maybe not. There we go. Is this increasing, decreasing, or constant? And remember, we read graphs left to right, okay? So as I go from negative infinity to positive infinity, would you say that this is increasing, decreasing, or remaining constant? And again, this is an exponential function of the form b to the x plus c, where our base, 1.2, is greater than 1, and then we've added some constant. Alright, let's look at the next question. So again, you'll select increasing, decreasing, or constant for that one. Now they say if a logarithmic function is of the form f of x equals log base b of x plus c, and b is greater than 1, then once again, are we increasing, decreasing, or constant? So I'm going to delete our old example, and we have to come up with a new one. So we need an f of x equals log, and we have to choose a base greater than 1. So I'll pick 10, that's our standard base, right, of x. So log base 10 of x. And I'll pick plus, 8, just to have some number there. Alright, so once again, I've picked a logarithmic function that has a base greater than 1. And the question is this logarithm increasing, decreasing, or constant as I go towards infinity? And I'll zoom in on this one a little bit. I know it's kind of hard to see it. So remember, reading left to right, if I scroll this way, does it appear that my function is increasing, decreasing, or remaining constant? Okay, and then here we are zooming out again. And remember, when we talk about constant, that's for the whole, the entire function. Alright, so just a hint on that. Constant would only be applied if we were looking at the entire function and the slope, the y value, never changed. So are we increasing, decreasing, or constant as we go towards infinity? Alright, so now you have a couple short answer questions. The first one says, Polly thinks that the graph of exponential and logarithmic functions are complete opposites. What do you think she means by that? Once again, I would pull up our graph, and what I would do is just graph. She says that she thinks the graphs of exponential and logarithmic functions are complete opposites. Why don't we graph a logarithmic function and an exponential function? So I'm just going to use kind of any standard example. I'm just going to do f of x equals 2 to the x as my exponential function, and then I'm going to do f of x equals log x as my, I need to name that function something else. F of x equals log x as my logarithmic function. Alright, so here you can see in purple I've got this exponential function. Okay, let me zoom in a little bit. And in blue I've got a logarithmic function. So Polly thinks that these functions are opposites. Okay, and the question is just, why do you think someone might look at exponential and logarithmic functions and say these are opposites? All right, so just take a moment to look at this. Again, in purple we have exponential, in blue we have logarithmic. What about this might make someone think the word opposite? So remember, when you do these short answer questions, explain yourself clearly. All right, think of it as a discussion post. Use the discussion rubric when you're answering these questions. One thing that'll help is to incorporate vocabulary from the lesson. So for example, it might be useful to use the word inverse in here. That might be a concept that comes in relevant for this question, okay? Explaining clearly and fully, as well as using vocabulary for the lesson. These are the factors you're going to need to score well on this short answer, all right? And one thing you may have noticed by now is that a lot of our short answer questions are worth more than other questions. Okay, so for example, a short answer question might be worth more than something like this, where you're just filling in blanks. Okay, that's not always the case, but for those of you who sometimes skip those short answer questions, I just did want to mention that they're often weighted heavier than other questions. So after you answer that one about why they are complete opposites, you have to talk about why they're alike. So Digit thinks that the graphs of exponential and logarithmic functions are more alike than they are different. So why might that be the case? So once again, pulling up this graph, we have f of x equals log x as our logarithmic, and then we have 2 to the x as our exponential, so the exponential in purple, logarithmic in blue. What about these are alike? So you might talk about some features that they have in common. It doesn't matter if the features are exact. So for example, I can see that both of these functions have asymptotes. It doesn't matter if the asymptote is defined at the same value, but that might be something that they have in common. That might be one reason why we think that these two function families are alike. Okay? And then once again, you might want to think about the word inverse and think about how we use what we know about exponents and logarithms to kind of convert back and forth between the two forms. What about that process might make you think that these functions are really more alike than they are different? And remember, there's no right answer here. This is more of like an opinion, subjective sort of question. But once again, I am looking for a clear explanation of what you think, why Digit might think that these graphs are more alike than they are different. I am looking for clear use of vocabulary from the lesson. And again, answer fully. Use the discussion board rubric to kind of gauge your response. And finally, so you've talked about why the graphs are opposite and why they are alike. Now, using your interpretation of those ideas in those last two questions, describe the relationships between exponential and logarithmic functions. So this time we're not prompting you to take a specific opinion. In the first question we said, Polly's opinion is that they are opposite, explain why. Then we said Digit's opinion is that they are alike, explain why. This time we're just saying, objectively describe the relationship between exponential and logarithmic graphs. All right, so I would recommend rereading your responses from the last two pieces. Take pieces of their ideas. I said that you agree with, that might not be the best way to say it, but the more important parts of their ideas, more relevant parts of these ideas, and discuss them. You could think of this as sort of a compare and contrast response as far as describing the relationships. What do these function families have in common? How are they alike? How are they different? What's the relationship between them? Okay? How are they connected? Would be another important thing to mention. So how are they connected? And once again, answering in complete sentences, a fully formed response will probably be about a paragraph. And that's it for this section of Project 3.